You ever just stop and think about the sheer amount of intelligence that's packed into the device you're holding in your hand? And I'm not talking about its internet connection. I mean a powerful, self-contained brain that works right there, on the device itself.
Okay, so picture this. You're on a phone call with someone and they're speaking a completely different language. But your phone, it's translating the whole conversation live, in real time. There's no Wi-Fi, no cell signal. How in the world is that even possible? I mean, it feels like straight-up magic, but it's not. It's actually the result of this quiet little revolution happening inside our chips.
And it's not just the live translation thing, it's how your phone unlocks the instant it sees your face, or how it can snap a bunch of photos at once and then, boom, stitch them together into one perfect picture. Or even how it can take your messy, rambling meeting notes and just hand you a nice, clean summary. All of this is happening right there on your device, without ever sending your private data up to the cloud. So, what is the secret sauce here?
Well, to really get what's happening now, we've got to go back a bit. We need to look at AI's power-hungry childhood. This was an era that was completely dominated by a piece of hardware that was originally made for something totally different: video games. The first hero of the AI story was the GPU, the graphics processing unit. Its superpower is something called parallel processing. Now imagine you have to solve, say, 1,000 simple math problems. A normal computer chip, a CPU, would do them one after another. But a GPU, with its thousands of tiny cores, it can do all of them at the exact same time. And that ability, that was a massive, massive breakthrough for training AI models.
But there was a huge catch. GPUs are the gas guzzlers of the computing world. They need a ton of power, and they kick out a ton of heat. Now that's fine if you're a giant data center with its own cooling system, but it's a complete disaster for something you want to fit in your pocket and, have the battery actually last all day.
So this power problem, it created a huge opening. The world needed a new kind of chip, not some general-purpose workhorse, but a lean, mean, efficient specialist that was built for one job and one job only: running AI. And that is the Neural Processing Unit, or NPU.
You can really think of it as a generalist versus a specialist. So a GPU is kind of like a handyman who shows up with this giant truck filled with every tool imaginable, ready for any possible job. The NPU, though, is more like a master watchmaker. They have this small, perfect set of tools designed for just one super intricate task. It does less overall, sure, but what it does do, it does with incredible speed and efficiency.
And to really make this click, there's this fantastic analogy that just perfectly explains the whole idea behind these two chips. Let's think about them like kitchen appliances.
So the GPU is like your big conventional oven. You can bake with it, you can broil, you can roast, it can pretty much do it all. But it takes a while to heat up, and it uses a ton of electricity, right? The NPU, that's your air fryer. It's designed to do basically one thing: make food crispy and delicious, and it does it unbelievably fast, using way, way less power.
It's all about picking the right tool for the right job. The GPU, our oven, is the generalist. Its strength is that it can handle any complex job you throw at it, which makes it perfect for the huge power-hungry process of training an AI model from scratch. But its big weakness is all that heat and power use. Now the NPU, our air fryer, is a total specialist. Its job is something called AI inference, which is just a fancy way of saying it runs an AI model that's already been trained. It's incredibly fast and efficient, which makes it absolutely perfect for your phone, your watch, your laptop.
So how does the NPU get so efficient? Well, a big part of the secret is its really clever internal design. Think of it like a perfectly organized assembly line. Instead of one worker running back and forth to a supply closet for parts, which is slow and wastes energy, the parts just flow smoothly down the line right to each worker. The NPU does that same thing with data, minimizing how much it has to move to save power and go way faster.
And this idea, it went from being experimental to being absolutely essential in just a few short years. I mean, back in 2016, Google's custom chip, the TPU, was the secret weapon that powered AlphaGo. Just 1 year later, Apple put a neural engine, which is their name for an NPU, into the iPhone. And now, it's becoming a key selling point for basically every smart device out there.
Because of the NPU, we are walking into a whole new era where powerful, local AI isn't some luxury feature, it's just the new standard for what it even means to be a smart device. This whole shift means intelligence isn't just up there in the cloud anymore. It's becoming a personal, private resource right on the devices we use every single day.
And we actually have a way to measure this intelligence now. It's called TOPS,
which stands for tera operations per second. It's basically a count of how many trillion calculations that little chip can perform in a single second. For the new wave of AI PCs, 40 TOPS is sort of the new baseline you need for next-gen features, like having an AI assistant that's always on, always running in the background for you.
And this right here, this is the real change. You know how we all learned to ask about gigahertz for a processor or gigabytes of RAM? Well, we're now starting to ask about TOPS. It's quickly becoming the single most important number that tells you how smart, how fast, and how capable your next device is really going to be. And look, this isn't just about our phones and our laptops anymore. The NPU is becoming the brain inside our cars, our watches, even our home appliances. The performance of that one tiny chip is directly tied to the smarts of whatever device it's living in. So let's look to the future for a second, because this all starts to build into something that sounds like it's straight out of science fiction. If the NPU is this specialized AI calculator, what could possibly come next?
Well, we're seeing two really incredible paths forward. The first one is called neuromorphic computing. This is, well, it's basically building chips that are structurally modeled on the human brain, with their own digital neurons and synapses. The whole idea is to get them to learn in a more natural way, using just a fraction of the power, so a device can actually adapt to you personally. The other path is something called processing in memory, or PIM. This tech basically erases the line between the memory and the processor, so calculations happen right where the data is stored. It's all about making things unbelievably fast.
The ultimate goal here, the big vision, isn't just smarter gadgets. It's what people are calling invisible intelligence. So imagine your smart glasses just subtly highlighting the name of a person you met one time a year ago. Or your kitchen suggesting a recipe based on the ingredients it sees you have out on the counter. All of it happening instantly, without ever needing the internet. That's the goal. This helpful AI that's just around us, assisting us seamlessly, without us even having to think about it. So as we wrap this up, here's the final thought I want to leave you with. The last big tech revolution, the smartphone, it put a powerful computer in your pocket and connected you to all the world's information. This next revolution, the one powered by the NPU, it's different. It's putting a dedicated personal brain in your pocket, a brain that learns, that anticipates, that helps you. So the only real question left is, what are you going to ask it to do?